Hello everyone, welcome back to Steadfast Skill Assessment Academy. In this video, I will explain the most important electrician practical interview questions and answers, arranged by topics like tools, wiring, transformers, and testing. These will help you prepare for skill assessments, trade tests, and job interviews. Let's begin. What is your name? My name is, and I am a qualified electrician with training and practical experience. I have worked on residential, commercial, and small industrial projects. My focus is always on safety, accuracy, and efficiency. I enjoy working with electrical systems and solving technical problems. Who is called an electrician? An electrician is a skilled tradesperson who installs, maintains, and repairs electrical wiring and equipment. We are responsible for safe distribution of power in homes, industries, and public places. Our job also includes fault finding, testing, and ensuring reliability. Without electricians, daily life and industries cannot run smoothly. What qualifications should an electrician have? An electrician should complete ITI, vocational training, or apprenticeship in electrical work. Along with theoretical knowledge, practical experience on site is very important. Safety training and awareness of wiring codes are also required. Employers look for certified and skilled workers. These qualifications prepare us for professional responsibilities. What should an electrician know in theory and practical? In theory, we must know about current, voltage, resistance, Ohm's law, and power. In practical work, we should handle wiring systems, load distribution, and earthing. Using tools and testing equipment is equally important. A good electrician applies theory into safe practice. This balance ensures high quality work. What knowledge do you have as an electrician? I have knowledge of hand tools, power tools, and testing devices like multimeters. I understand different types of wiring, such as staircase and go down wiring. I follow PPE rules and electrical safety standards. I can work on both AC and DC circuits. This knowledge helps me complete projects with confidence. Explain the types of wiring you know. I know staircase wiring, tunnel wiring, hostel wiring, and go down wiring. In staircase wiring, a single lamp can be controlled from two switches. Tunnel wiring is useful for long passages with continuous lights. Hostel wiring is designed for multiple rooms and high load. Go down wiring is used for storage areas. What is the difference between hand tools and power tools? Hand tools are manually operated, such as pliers and screwdrivers. Power tools run on electricity or batteries, such as drills and grinders. Hand tools are suitable for small or delicate tasks. Power tools save time in heavy work and increase efficiency. Both are necessary in electrical jobs. Give examples of hand tools. Hand tools include screwdrivers, pliers, wire strippers, spanners, and testers. Screwdrivers are used to tighten or loosen screws. Pliers are used for gripping and cutting wires. Wire strippers help remove insulation, and spanners are used for bolts. These are everyday tools for an electrician. What are power tools? Give two examples. Power tools are electrically operated devices that make heavy work easier. For example, a drilling machine is used to make holes in walls for wiring. An angle grinder is used for cutting or grinding metals. These tools save time and effort in installations. Safe handling is always important. What are the uses of combination pliers? Combination pliers are used for gripping, bending, twisting, and cutting wires. They are versatile and useful in both installation and repair jobs. They can also hold small objects while working. Every electrician carries them as a basic tool. They make tasks faster and more convenient. What is the difference between AC and DC? AC means alternating current, where current changes direction at intervals. DC means direct current, where current flows in only one direction. AC is commonly used in homes, industries, and transmission lines. DC is used in batteries, solar systems, and electronics. Both are important in electrical engineering. What are the full forms of AC and DC? AC stands for alternating current and DC stands for direct current. AC flows in two directions periodically while DC flows in a single direction. AC is widely used for transmission and distribution. DC is used for small circuits, backup, and storage. These are the basics of electricity. What is the frequency of AC? The frequency of AC supply in 50 Hz. This means the current changes direction 50 times every second. Maintaining frequency is important for the smooth running of machines. In countries like the USA, the frequency is 60 Hz. Each country follows its own standard. What is a transformer? A transformer is a device that increases or decreases voltage without changing frequency. It works on electromagnetic induction. Transformers are essential for power transmission and distribution. They reduce losses and improve efficiency. They are a backbone of the electrical supply system. What does it mean when a transformer is called a static device? A transformer is called a static device because it has no moving parts. It transfers energy only through magnetic induction. Since it has no rotation, it needs less maintenance. It is efficient and reliable. That is why it is widely used in power systems. What is the main function of a transformer? The main function of a transformer is to change voltage levels. Step-up transformers increase voltage for transmission. Step-down transformers reduce voltage for safe usage. Transformers also minimize power losses. They make electricity distribution safe and efficient. How many types of transformers are there based on voltage? Based on voltage, transformers are two main types: step up and step down. Step up increases low voltage into high voltage. Step down reduces high voltage into usable low voltage. Both are important in supply systems. Special types like isolation and auto transformers also exist. What are step-up and step-down transformers? A step-up transformer raises low voltage to high voltage for long-distance transmission. A step-down transformer reduces high voltage to safe levels for homes and industries. Both work on electromagnetic induction. They are essential in power systems. Each has its specific use. Where is a step-up transformer used? Where is a step-down transformer used? Step-up transformers are used in generating stations to transmit power over long distances. They reduce current and losses. Step-down transformers are used in local areas to supply safe voltage to consumers. For example, 11 kilovolts is reduced to 230 volts or 440 volts. Both are critical in distribution networks. What is the significance of primary and secondary windings in transformers? The primary winding receives the input voltage. The secondary winding delivers the output voltage. The ratio between them decides whether the transformer is step up or step down. Copper is mostly used for winding material. Proper insulation ensures efficiency and safety. In local transformers used in villages or towns, is it step up or step down? In local distribution, transformers are always step down. They reduce high voltage to safe levels for homes and shops. For example, from 11 kilovolts to 230 volts. This prevents damage to appliances. Step-down transformers are essential in towns and villages. In what units is the rating of a transformer given? The rating of a transformer is given in kilovolt ampere or megavolt ampere. These are units of apparent power. Unlike machines, transformers are not rated in watts. This is because they handle both active and reactive power. Ratings define transformer capacity. What is the full form of kVA and MVA? kVA stands for kilovolt ampere and MVA stands for megavolt ampere. These are used for transformer and alternator ratings. They measure apparent power. kVA is used for small to medium transformers. MVA is used for large power stations. How do you know if a machine's rating is in watts, kVA or MVA? Machines that convert power into work, like motors, are rated in watts. Devices like transformers and alternators are rated in kilovolt amperes or megavolt amperes. Small appliances use watts. Large power equipment uses kilovolt amperes per megavolt amperes. The rating depends on the type of power handled. What is a winding in a transformer? A winding is a coil of insulated wire wound around a transformer core. The primary winding is connected to input and the secondary to output. Winding material is usually copper or aluminum. Windings enable voltage transformation. Their design affects efficiency. What types of windings are there in a transformer? There are two main types, primary and secondary windings. The primary receives input and the secondary delivers output. Some transformers also use tertiary winding for special purposes. The ratio between windings defines voltage transformation. Proper winding design is important for performance. In a three-phase transformer, what types of connections are used? In three-phase transformers, star Y and delta delta connections are used. The primary may be in delta and the secondary in star. Star connection provides neutral and is suitable for distribution. Delta gives stability in transmission. Both are used depending on requirement. In local distribution transformers, which connection is in primary and which in secondary? In local distribution, the primary winding is connected in delta. The secondary winding is connected in star. Delta reduces insulation requirements on the high voltage side. Star provides neutral for household supply. This combination is standard in distribution. How are street lights connected, series or parallel? Why? Street lights are always connected in parallel. In parallel connection, if one light fails, others keep working. Voltage across each lamp remains the same. This ensures proper brightness and reliability. Series connection is not practical for street lighting. Explain the reason for using parallel connection in street lighting. Parallel connection gives equal voltage to each lamp. It prevents total blackout if one light fails. It is easier to maintain and repair. Parallel connection also saves energy losses. Therefore, it is the best choice for street lighting systems. Which tool will you use to check the voltage of a battery? To check the voltage of a battery, I use a digital or analog multimeter. It is reliable and easy to operate. The multimeter shows exact voltage readings. It helps to confirm whether the battery is charged or discharged. This tool is essential for electricians. How will you set the multimeter to check the voltage of a 9-volt battery? To check a 9-volt battery, I set the multimeter to DC voltage mode. Then I select a range slightly higher than 9 volts, like 20 volts. The red probe is placed on the positive terminal and the black probe on the negative terminal. The display will show the battery voltage. How do you measure resistance with a multimeter? To measure resistance, I set the multimeter to the resistance ohm mode. I connect the probes across the resistor. The meter displays the resistance value in ohms. This helps in checking whether components are working properly. Resistance testing is important in circuits. What precautions should be taken while measuring resistance? While measuring resistance, the component should not be connected to power. We should not touch the resistor with bare hands, as body resistance may affect the reading. Probes must be connected properly. The multimeter should be set correctly. These precautions ensure accurate results. Why is there a difference in measured and actual resistance? Tolerance. The difference occurs because every resistor has a tolerance value. Environmental factors like temperature can also affect resistance. Manufacturing variations are another reason. Multimeter accuracy may also vary slightly. Therefore, readings may not exactly match the rated value. What does it mean if the resistance reading is higher or lower than expected? If the reading is higher, the resistor may be damaged or overheated. If it is lower, the component may be shorted or faulty. In both cases, the resistor may not perform properly. This can affect the entire circuit. Checking tolerance helps in identifying the problem. Can you demonstrate checking resistance correctly? Yes, I first disconnect the resistor from the power source. Then I set the multimeter to ohm mode. I connect the red and black probes across the resistor terminals. The reading shows the resistance value. I also compare it with the rated value for accuracy. Thank you for watching this complete guide on electrician practical interview questions and answers. I hope this structured explanation will boost your confidence for skill assessment and practical tests. If you found this video useful, don't forget to like, share, and subscribe to Steadfast Skill Assessment Academy. See you in the next video.